That's how you can go from, so you can go from one form to another. And because of the, and let me just say this also, this is the form from the definition that we have, okay? And again, the domain is all real numbers. But what's nice is we don't actually have to convert to standard form. That is, we don't have to complete the square because it turns out there are formulas for the vertex, and that's what these are. And this is the axis of symmetry. Again, that's the vertical line through the vertex. So if for some reason we did not know these formulas, for whatever reason, then we would have to complete the square. What I'm showing you here is, well, no, that's not the case. These A's are the same. It turns out this H is actually equal to negative B over 2 times A, and K, you just plug it into F. That is, K, you just replace X by. No, excuse me, you replace H by X in here to get K. So we don't have to complete the square is what I'm trying to say. Generally, what's going to happen is I'll give you something like this, and then you can use these formulas to get the vertex, the axis of symmetry. You will have to calculate some intercepts, the X and Y intercepts, and then you could just sketch the graph. And even if I did give you this form, you can convert it easily to this form by just foiling. I mean, this form does have uses, don't get me wrong, the standard form. Not today, but Friday, the kind of example we'll see is come up with a quadratic function that has a certain vertex and passes through a certain point. Or if I give you the graph of a quadratic function, you can easily come up with a formula for it using the standard form. So the standard form is useful, don't get me wrong. And again, if you know about vertical and horizontal shifting and translations, you could actually graph more easily using the standard form. Okay. So from here, let's look at this again. I keep saying the domain is all real numbers. That's important. The y-intercept is easy, right? That's just where it crosses the y-axis. That's just f of 0. In other words, you just replace x by 0 and solve. The x-intercepts, okay, you have to solve this equation. In other words, you're going to have to solve this. If you do have the standard form, you can proceed that way. I would just FOIL and go from here. Again, we're going to have to use what we saw in section 1.2. I mean, factoring or quadratic formula. Although usually in this case, we're going to use the quadratic formula. So factoring, as we know, has its uses. And this just tells you how to get the range. I mean, it's really just visualization, but even if you didn't have the graph, but you know the vertex and you know what A is, you can still figure out the range though. And that's what this is saying. So it's always going to be from some number to infinity or minus infinity to some number. So it's always going to look something like that. Mostly because the graph either goes up forever or goes down forever. All right, now, for some reason I had the slide repeated twice. I don't know why, but that's all right. Anyway, here's an example I want to go through. So let's say I asked you to graph this function, okay? This quadratic function, that is. Now, okay, so really what you want to do is I have here, you really want to get A, B, and C first. Then you're going to use the formulas. I mean, if we didn't have these formulas for whatever reason, then you probably would have to complete the square. But what's nice is by those formulas, we don't need to, because we can get the vertex. So here's our A, right? That's the leading coefficient. Our B is 8. And our C is minus 3. Okay? And right away, you can see that, well, this graph is going to open upward. So it's going to look something like y equals x squared. Or what we saw today, y equals x squared plus 1, because the a is positive. Remember, a cannot be 0. It has to be then positive or negative. That's also why this makes sense, because a cannot be 0. If you went back to the formulas, you would see that you would have to calculate this. Again, I did email you the notes, so you should have them. Actually, you know what the heck? Let me just go back. But here, basically, we would have to calculate negative b over 2 times a, for the axis of symmetry and the vertex. And we have to get the function value, the function evaluated at that. So that's what we would have to do. Okay. I had to delete that slide. Okay, here we go. So here we're doing that, and we get negative b over 2 times a. And as you can see, we're going to have negative 8 over 2 times 2. That's negative 8 over 4, which is negative 2, as we can see. So we know x is negative 2. So that's the x coordinate of the vertex. And the vertical line, the axis of symmetry, is x equals negative 2. But we need the y coordinate, right? That's the function value. So we plug it into the function here. And, going through the calculations, we get negative 11. I mean, you can check my calculation. I'm pretty confident this is right. But basically, what we get then is the vertex is negative 2, negative 11. The axis of symmetry is x equals negative 2. And again, you can get the y-intercept easily. You just replace x by 0. Although in this form, it's actually even easier because it's just the constant term, which in this case is minus 3. In other words, it's just c. So we have almost everything we need. We have the vertex. We have the axis of symmetry. We have the y-intercept. Really, the only thing left is the x-intercept. And again, that's when we solve the equation when this is equal to 0. And I'm using the quadratic formula. So remember, this is what it is, the formula, that is, quadratic formula. Remember, I did this the other day, but what's under the square root sign, that's called the discriminant. So in this case, we're going to get this here. Again, I'm just taking a, b, and c and plugging it in. So b is 8. So negative b, negative 8. Plus or minus square root of b squared, which is 8 squared, minus 4 times a times c. And we get all this. Now, in this case, what I would do is round off, using your calculator. I actually used Excel instead of a calculator, but, either one is fine. I mean, normally I would tell you how many decimal places to round off. I did, it's like one case I did 5, one case I did 6. But normally I would tell you how many decimal places to round off. But you can see from here also, we're getting 2 solutions, right? 2 values for the x-intercepts. I mean, hopefully you can see that, right? We have negative 8 plus the square root of 88 over 4, negative 8 minus the square root of 88 over 4. Again, I just calculated these in decimal form. Once we do that, we basically have everything we need. I mean, normally I probably would not ask you to graph it by hand. I might just say calculate the vertex using the formulas I gave you. I know there's like Desmos and stuff out there. I can graph it for you. But basically here is our vertex. Here, that's our y-intercept, right? Here's our x-intercepts, as you can see. And you can see that the graph is opening upward as we knew it would. And I didn't sketch the axis of symmetry, it is the vertical line here through the vertex. So that's what we get here. And you can see that the range, actually, let me see if I can draw the axis of symmetry. I might be able to. So I'm going to draw it as a dashed line somewhat. I mean, I know this is GeoGebra I use to graph it, and you can graph vertical lines in there. So hopefully that's what I'm trying to do here. Hopefully you can see that, you know, that's the axis of symmetry, and hopefully it appears that the graph is symmetric about this line. Again, that just means if you take the graph and fold it about this line, both halves would line up. And hopefully you can see also the range is from -11 up to infinity. I mean, essentially, it is the y coordinate of the vertex. You're either going to go to infinity, as in this case, or you might go to -infinity. But hopefully you can see that the range is -11 to infinity. We're including the vertex. We're including -11 heads. You know, how can we see that otherwise? Well, you can draw these horizontal lines. You can imagine projecting it onto the y-axis, right? And basically, if you do that, you would end up getting, let's see if I can draw it right. Oh, goodness gracious. Hopefully you can see that, yeah, we are getting, in fact, oh, except for this piece, -11 to infinity. Oh my goodness. One day I'll get art lessons good. Anyway, we have that example. We can draw it. Okay. So we have that. I mean, in class, normally I would give this like as a question, but I wouldn't let you use a graphing calculator. So let me just, here.